I started talking to Stuart and to Anatuela a little about what they had been doing in the past, and I discovered that something I was currently working on, LIWC, which is a linguistics analysis tool, which I was using to analyze tweets that were being sent out by simulation analysts, would tie in nicely with some data which they had. So this study is kind of based on that, and we're looking at the idea that, I guess, are you using the right simulation tool for the right problem? And so this is kind of where this study falls. And so to start with, everybody here probably has their own favorite technique or their approach. I come from a discrete event simulation background. I worked for almost a decade as a simulation analyst for the Jervis Webb Company doing manufacturing simulations prior to coming into academics. So I probably had a little bit of a bent to this study thinking, oh, I know discrete event simulation is better for every type of problem. And suddenly I realized that perhaps that wasn't the case. Now, if I say anything embarrassing or wrong here, it's all on me. If I say anything great here, contribute that to Stuart and to Antuela. So don't let me reflect on them at all with this talk. So we're going to look at some different approaches, and all of you are experts in these areas. You know how they overlap, when they should be used, when they shouldn't be used. But that's not the case for everyone. And I've got a short video here that's going to kind of illustrate what typically goes on in industry in these kinds of situations.
Miller, glad I ran into you. We need to talk.
I was afraid of that. I am really busy today.
Not too busy for this. I have a really big problem to solve and was told you are the man to help.
I am good at problem solving and decision support. Maybe I have a little time. Can you describe what you need help solving?
It is a complex managerial problem with potentially corporate disrupting consequences.
Great. That is my favorite sort of problem to solve. I need details to support my analysis.
Did I hear someone say something about problem solving and decision support?
No, we were talking about football.
No, you were not. You were trying to get Colin to use your discrete event computer simulation services.
It's better than your system's dynamics approach to solving managerial problems. Colin needs a detailed analysis for a potentially corporate disrupting decision here. I am clearly the man he needs to see.
He needs system dynamics. SD is certainly the best for strategic corporate decision analyses. He needs conceptual modeling for sure.
I haven't even described the scenario yet.
No need for that, Colin. I will handle this with discrete event simulation. Catherine can just leave. I am sure you want to solve an operational, stochastic, detailed problem. I will use probability distributions, entities with attributes, randomness, numeric descriptors and some judgment elements. We will use queues and activity networks. I will focus on distinct individual characteristics. I will incorporate unequal time steps and provide statistical output for what-ifs.
What I really need is...
Don't listen to his DES drivel. I will be strategic, deterministic, continuous, holistic, aggregate, and big picture in my analysis. I will show time in a reservoir setting with flexibility, homogenized entities, continuous change. It will be policy and structure driven, focusing on broad outcomes. I will use a closed-loop structure with feedback. A series of stocks and flows will illustrate all objects. I will solve your corporate-level problems and save all our jobs.
Just leave Catherine. DES will take care of this situation. SD is not the best choice.
I was just going to ask where I should put the coffee pot while the break room was being repainted. You people are crazy.
The details of a coffee pot movement are certainly better captured in a DES application.
It is homogeneous and better modeled as inflows and outflows. That should be obvious even to a toddler. Coffee is a liquid already in a reservoir, perfectly suited to SD modeling.
We may have to agree to disagree. In the meanwhile, how about getting a coffee? I like mine black. Sugar is bad for the teeth.
Black coffee is too acidic. A flat white is a much better choice.
As usual, you are wrong. I could get to like this, I think.
Okay, so that little, I guess, clip kind of summarizes many of the differences and similarities between DES and SD without me getting into kind of a boring sort of description in detail about what these things are going on. But the purpose of the study at hand really was to kind of look at the cognitive processes that go on behind the scenes in SD and DES development, and then determine if the characteristics suggested in the literature actually match and are manifested in what the individuals are doing while they're developing models. And so to do this, what we did was we wanted to, first of all, understand how both, how end users perceive these models, and we found, or the literature suggests that they're not significantly different in their perception. So people who are using the tools, maybe not as experts, but getting them, don't always understand there's a difference in when they should be used. Both approaches want to build accurate representational models, lead to decisions, and both of them can represent reality with equal validity according to some past studies. So in spite of my own background, I tried to ensure this study does not promote either approach as a superior approach in all situations. So what we want to do is really look at the differences in these two approaches from a theoretical perspective. And this took place in a literature search, and you heard the people talking about the differences in structure, inputs, the way the models are developed internally, the way usage is viewed by the people making decisions, how each language or each approach has a different kind of approach to what if or decision making, and how the different models are constructed. So I don't want to spend a lot of time getting into this too much, but what I do want to talk about is how the study methodologically progressed. So we had a set of data that was collected earlier, and it was used to model some prison population problems. So the data was collected using a quantitative research method called verbal protocol analysis, or VPA. And this approach kind of takes the idea that as subjects develop a model, they talk aloud, and this information is recorded. So we had 5 simulation experts in the SD area and 5 simulation experts in the DES area. This data was actually collected in a different study, but we were able to reuse it for this particular analysis. So the 10 experts all had a good background in simulation in their particular area and are considered experts by virtue of experience and background. So they were all people that knew exactly what they were doing in this particular approach. So during this model development process, their language was captured into, a text file, and then it was taken into a computer program called LIWC. And that is going to allow us to kind of analyze the differences in what people are thinking about at the time they're actually going through the model development. So we ended up using LIWC, which is a piece of computer software developed by Pennebaker, Booth, and Francis at the University of Texas. And what it does is it goes through and analyzes and counts words in psychologically meaningful types of ways and puts them into dimensions. This piece of software has been used extensively in the past few years to help look at maybe the underlying cognitive processes that are going on in people's minds as they're writing or speaking or doing other kinds of things. You may be thinking, this is kind of getting out there into the social sciences realm a little bit, and it kind of is. One of the leading studies that was used to validate it was done on a set of poetry done by poets whose lives ended through a suicide or not. And so what the researchers did is they took a big sample of poems that were written by each poet, and then they used LIWC to analyze the types of psychological dimensions that seem to be underlying their work, and then used that to determine whether or not they appeared to predict a suicide event, and was very successful in doing this. The same software has been used in a variety of other instances in business and in social studies to kind of look at what people are actually thinking about based on the words that they use. So our hypothesis really was that people using SD should be looking at policy-driven decision-making. They should be looking at the big picture, at conceptual models. And DES users are typically going to be looking more at the detailed focus level. They're going to be looking at the entities and so forth. And so the differences that are theorized should manifest in the types of language usage by the individuals in each area. So our primary analysis was going to look at how these different types of text files or these data sets are going to be matched up according to approximately 70 different dimensions, and we are using t-tests to look at the outcomes and what happened with this. So general review of the data, like I said, it had a set of transcripts in each area. The transcripts were approximately 5,394 words long. The cleaned SD transcripts were a little bit shorter. Kind of makes sense, I guess, if you're thinking about DES is typically a more detailed type of approach, and this is more of an overview, policy-driven type of approach, strategic. It's consistent with DES focusing on details and SD on overview. Words per sentence were nearly identical, so the structure and grammar and the type of background of the people indicated that the speakers had significantly, or had similar cognitive complexity in their thought and speaking process. So we didn't find that SD speakers used shorter sentences and simpler words or anything like that. Both populations were approximately the same education level and used the same type of sentence structure, and there were some other statistics that also backed that up. So then I started looking at some of the different possible things that needed to be understood, or some of the different dimensions. And there's actually 22 different hypotheses that were looked at. These were derived from the literature, looking at which type of tool was likely to manifest in a higher use of a particular set of psychological correlates. And so the ones that came out to be significant, I'm going to just kind of spend a few minutes talking about right here. We looked at, first of all, I guess this one probably isn't going to be too significant in terms of the overall study, but the first hypothesis was that words that were over 6 letters long would be more likely to be correlated with social class. And this was based on some literature review that we did. And we found that in the SD area, it was typical that people were using more complex words to describe things. And so that kind of correlates, according to the LIWC's body of literature, that social class is going to be typically higher managerial type individuals that are involved in this particular area. Another area that came out significant was in terms of personal pronouns. By using personal pronouns, you're kind of indicating that an operational or a personal or individual representation is going to be taking place. That correlated more highly with DES than with SD. So again, this is kind of more detailed level, this is more strategic level, and that kind of bore out what the literature was saying a little bit. In terms of insight, we found that insight's another dimension that was significantly higher for the SD area. It just kind of shows that SD is going to provide a learning potential and understanding of the big picture. Again, this measure kind of correlated closely with SD use and the SD linguistic constructs that were developed. We looked at inhibition that describes constructs, stops, and problems. This dimension correlates with the ideas of maybe, perhaps, and guessing a little bit in terms of LIWC's body of literature, and we found that this was significantly higher in the DES area. So again, focus on looking at detailed, finer resolution, more items coming under close scrutiny. Again, this kind of bore out the fact that analysts using DES were more working in the detailed area. A few more of the interesting findings were that perception showed a significant difference. We found that DES related to observing, hearing, and feeling came out higher in that particular area. We believe that DES required more detail in developmental stages, and it has more of a visual perceptual output a lot of times. So in terms of animation and other things, the analysts appear to be thinking more about perceptual related items when they're working in developing discrete-event simulations. A few more, seeing kind of highly correlates with the visual component again, with DES. And the physical perspective also loaded higher for DES. So the physical perspective, types of words relating to that type of approach. In terms of motion, again, DES loaded higher on this one. Again, thinking of transactions and movements through different types of systems came out a little bit higher. And then finally, we had DES transcripts containing more questions, and the analysts were oftentimes asking more kind of detailed sorts of things. So if we look at the overall sets of analyses that were done, we had 22 hypotheses that were all dimensions from the 70 that LIWC looks at. We formed a hypothetical relationship based on the literature. We went through and tested the dimensions based on the LIWC outputs. And as you can see, some of the outcomes were supported, some weren't. The ones I went through were the ones that came out as significant. I think the key findings for us were really that the cognitive processes that you might expect to be associated with the experts in each area is manifested in language dimensions were actually consistent with what the literature shows in the SD and DES areas. Didn't really find anything that was totally unexpected, which I think was kind of good. We had a few dimensions that we discussed and talked about a little bit, but the word choices really tend to indicate that analysts using the SD approach are more strategic, and they correlate higher with dimensions consistent with language use in an executive rather than an operational or tactical setting. So we felt that the dimensions that came out in the SD transcripts were actually consistent with what the literature shows. Same in the DES area, the users focus more on personal involvement, individual representations, detailed questions, more of a detailed kind of approach to the model building. So these significant differences, I guess, provide more empirical evidence to support theoretical beliefs that SD and DES should be used in appropriate ways. SD is more strategic, involves kind of a more of a overall conceptual sort of modeling approach, and DES is often going to be more in the operational detail area. So that's kind of where we ended up with our study. I think it was kind of an interesting validation of what we see in the literature a lot of times. Many of the papers in the past have been kind of a opinion based, based on personal opinion. This is kind of a way to look at it in a more formalized setting to try to understand if what's in the literature does in fact match up with what seems to be discussed. So I'm happy to take any questions at this point.
Any questions?
As I recall, that data set was collected by modelers sitting in a room on their own in front of a computer with a problem that they were given on a piece of paper. I just wonder if you've done the experiment actually interactively with a client presenting the problem. You would have got the different.
That would be very interesting to do. I think it'd be a great follow-up. Now that this is all developed and we have all the statistical programming and so forth done, it would be an excellent way to do that. And I'm really open to expanding this to another approach, another set of data. So, yes.
So can I just understand, was it the same problem being talked about by the two different classes of
Yes.
analysts?
Yes.
Right. I think this is really fascinating and interesting and could lead to all sorts of interesting things, but it doesn't really divide problems up. It shows what the language is that's used by the analyst who has already been conditioned to a particular way of thinking.
Yes.
And I don't know, it might be interesting to kind of take a problem that over years everybody's worked out is better solved by SD, and a problem that over the years goes into the other camp, and actually give those two different sets of people to talk through. Because in a sense, you don't want to divide up the analysts.
Right.
You're trying to divide up the problem.
Right. I completely agree, and that is maybe one of the limitations here is that it was the same problem, and maybe that problem is not suited for both approaches equally well. It was interesting, though, to see from the transcripts, which I spent quite a time combing through, that they did each approach the problem from their background and perspective, and it did make a big difference in how they actually built or suggested the problem should be solved. And I think that therein lies one of the dangers. If a problem is given to someone trained in a particular area, they may sometimes not necessarily think outside of their box or pass it to another person. I think both languages, or not both languages, but both approaches could probably be used to solve the problem that was used here because it was sufficiently vague or open enough to kind of allow both approaches to find something significant.
Yeah.
Other types of problems would not be the same case.
Just comment on because we set up the original problem. It was deliberately set up to try and be amenable to both approaches. What was fascinating with it was that we simply gave this. It was about modelling the UK prison population. It was actually based on a case study from the late 90s by the Home Office, where they'd used a slightly differential equation type approach originally. But what was I think interesting is that we basically said, here's the problem, we're going to watch you build a simulation of it. Everybody, to a person, just simply used either, if there was a system dynamics modeler, they used system dynamics, or a discrete event modeler, used discrete event. in one of the pilots, I seem to remember, there was one discrete event modeler who briefly said, "Oh, it looks a bit like a system dynamics problem," and then went away and built a discrete event model of it. So it was just interesting that people were so conditioned to their own approach that they didn't actually even question whether the alternative was something they should be using for this. But I agree with the comment. I think it would be. I mean, it was obviously very artificial in the sense of we're going to watch you build a model. It was Antuela who sat in the room with them, and her only role was to say, "Keep talking if they shut up for a while." And the other thing, of course, would be interesting to see them work with clients, and also the issue that there are problems which are clearly, amenable to one approach and not the other, and whether that would actually lead to different. People say, "Oh, actually, I can't use system dynamics. I'll go and use discrete event." I don't know.
Yes.
Is this modeling about conceptual modeling only, or are you talking about implementation here? Because I remember Stuart said at some point that the conceptual model should be independent from the method you want to use. And therefore, if you look at conceptual modeling, people shouldn't decide beforehand what they're using. But did you look at implementation?
Well, in this one, they took it to a certain degree, and Stuart can probably clarify this a little bit further than I can.
They actually built the model.
They built the model.
In the software. So.
Did they also have to build a conceptual model first, independent from that? Because that would also be interesting to see if the conceptual models are similar, and then the implementation is just taken.
We have got.
PS or SD.
We kept copies of any scribbles. I've not looked at them in detail. I think that would have given a hint. There was no official conceptual modelling stage where, of course, the concept of the model was then embodied in the way they built it, and they would be very different because simply the DES modelers modelled individual prisoners running around the system, and the system dynamicists didn't. So conceptually, there were quite significant differences. But no, they were going right through to actually building, even running the model in some cases.
What would be interesting, what you're talking about, is to have someone do this exercise with the conceptual stage only, and then analyze the language and see what camp the language falls into during the conceptual stage to see if it might be better solved with one problem than the other.
To what extent was the problem artificially time-bound? In other words, a reason for not going through a formal conceptual modelling stage when someone's expecting to build a simulation is they're giving you relatively a tiny amount of time to get there.
Yeah, I'm thinking that they probably had a time constraint.
Yeah, I mean, we're dealing with people, reasonably senior in some cases, and certainly consultants, so they weren't going to spend days on this. I mean, they were basically taking somewhere between an hour to an hour and a half, I think, for these sessions. So it was a fairly well-structured, deliberately, rapid problem to work on because of the nature of the work that we did. Also doing a verbal protocol analysis on days of people analysing would have been quite exciting to produce transcripts for. So, yeah, I mean, there are limitations in that respect, but I think it's interesting that it does draw out some of the differences that we were expecting. I think interesting when Roger was talking about doing this what I call micro-level analysis, it clearly drew out some of those differences again.
There were some differences that, of course, did not come out that we expected. And part of the future of the study could be to see why these differences didn't appear. It may be related to the methodology of our study, or it may be that there's some crossover that we weren't expecting. So.
Are there any implications for people who work with both methods? I know Sally certainly had a couple of PhD students who actually combined the two. Are there any implications in terms of combining different ways of thinking from this work?
I think when I think about the outcomes, I think it would be very interesting, or maybe perhaps a very strong way of using these findings would be to, at the conceptual stage of the modeling, incorporate more of the SD type thinking, and then when it gets into maybe perhaps a position where more detailed information is required on the actual operations, then move into more of the DES area. I think it could indicate that both tools could be used on the same problem in some cases effectively.
Question. Could you explain a little about LIWC?
Yeah, LIWC actually a statistical program that was written by professors at the University of Texas, and what they did was they analyzed lots and lots of writings, and they derived from those psychological constructs that were in 77 different areas. And each one of those areas then, by looking at different writings, they kind of come up with a score in each area, and then that indicates the type of cognitive process that's going on in a person's mind as they're actually composing this work. So they validate it by creating a data set originally, and then they run other works through it to kind of come up with a validation of what they found. And they said the poetry one was one to try to kind of tease out an underlying depressive theme that's inside of the work, or other dimensions have other types of words they look at. So it's got a highly theoretical background, but they've taken it through